Hello and welcome guys. So in the last video we have completed our model prediction on new audio files. Like here we have taken some random audio files and this is our prediction. Okay. So in this video we are going to build a web application. Let me show you what we are going to build here. So this is a web application which we have created using Streamlit. If you don't know about Streamlit, then please watch the tutorial video. I have added that video in the playlist. Okay. So Streamlit is a Python library using which you can build a very interactive web application easily using Python. We don't need to use HTML, CSS, JavaScript, these UI parts. Okay, we can easily build any web application. So this is a UI of our Streamlit web application. So this is a home page. So this home page consists of all the details about the project, how this UI, how this web app works. All the details is present here, and in this about project, this is all about our project. So this I have taken from Kaggle. Okay, so once we start building this project, then I will do everything in front of you, then you will understand how we have done this. And then this is our prediction page. So here we will upload our test music file, and we will also play that music, and also will perform a prediction by clicking this button. Okay, so let me take some file from here. So I'm taking some file from here, like I'm taking first some jazz music I'm taking. Okay, so I'm playing it. So this is jazz music. So let's do a prediction and see what our model is saying. So our model is saying that it's a jazz music. Okay, so similarly we will do for other musics, like we will take some hip hop music, and we can also play by clicking this from here. If you click this, then you will get this thing and you can play from any part. Okay, and I'm doing a prediction by clicking this button. So our model is saying that it's a hip hop music, and we have uploaded this hip hop music. Okay, so from here we can upload any file and we can do a prediction. Okay, and also we can play that music. So this is our web application. So this app we are going to build in this video. Okay, and if you're new to this video, then please watch this playlist from beginning. Okay, so in this playlist we have done lots of things. Like first we have started by doing the visualization of that audio files, and then we have understand what is spectrogram and how we can use spectrogram to extract the important feature from the audio file. Okay, so these things, and then we have used the power of CNN, convolutional neural network we have used, and we have feeded that spectrogram, and we have built this model, and also we have evaluated our model. So lots of things we have done in this entire playlist. Okay, and then we have also seen how we can do a prediction on some new audio files. So this is what we have done in the last video, and in this video we are going to build this web application. Okay, so let's get started. Okay, so right now I'm closing this. So I'm going in my directory. So this is my directory in which we are going to work. So this is my music genre classification demo directory. In this directory we have this train music IPYNB file and test music genre IPYNB file, and this is our save model in the form of h5 file and keras file, and this is my training history. So here we are going to and we also have this test music in which we have these things. Okay, so we are going to use VS Code. So if you don't have VS Code, then please download VS Code or any text editor. Okay, so I'm going inside VS Code. So this is my VS Code. So I have to open first that demo directory. So let's go here and search that folder. So inside in my desktop I have this one, music genre classification demo. So let's open this folder from here. Okay, so we got our everything, like test music is here, and train music genre and test music genre, everything is here. Okay, so right now we need this because I already talked in the last video that we are going to use these functions in our web application. Okay, so we are going to use this. So first let's create one file here. So I'm creating one file named as music genre app.py. Let's right click on this and open your terminal from here. So by doing this you will be in the same directory in which this music genre app file is. Okay, so if I do pwd, then you will get this. So this is the same directory in which I have my all the things, okay, like model and everything. Okay, so that's why please open from here. Okay, and your terminal will open in that directory. Okay, so first, if you don't have Streamlit, then you have to install by doing like this, pip install Streamlit. If you do, then you will be able to install Streamlit. Okay, I already have Streamlit in my environment. And one more thing, we have to activate our environment. So here first we have to activate my environment, conda activate TensorFlow. Inside this you have to install your Streamlit. Okay, like whatever environment you are using earlier to train your model, in that you have to install Streamlit. Okay, so first we have to import our Streamlit. So import Streamlit as st. Okay, and then we also need TensorFlow. So import TensorFlow as tf and import numpy as np, and we need librosa also. So import librosa, and we also need resize. So import from TensorFlow dot image, import resize. Okay, so this library we need. If I if I do Streamlit run, and if I give this music genre app.py, so to run this Streamlit code, you have to run by writing this command Streamlit run music that app file. Okay, so here my file name is music genre app.py. So you have to write like this Streamlit run and your app name with its extension, and if you click it, so your Streamlit UI is visible at localhost 8501. So currently there is nothing, so that's why it's giving like this. Okay, so now what we have to do, we have to define first our function. So some function we have to take. So first function is our load model function, which will load our pre-trained model which we have saved earlier. Okay, so right here this load model. Okay, and in this function we have to pass this thing. If you go in this test part, so here we have already loaded our model, so this thing we have to use. Okay, so this thing we have to use here. Model is equal to tf.keras.models.load model. We have to use tf TensorFlow tf we have already imported. So this model we have to pass, and the path we have to give like this. So right now I'm using this thing train model.keras. So in the same hierarchy we are working. So perfect, and then we have to return this model, return model. Okay, and then what we have to do, we have to use that load and preprocess audio data function also. So that function I'm going to use from there. Okay, so this function we have to use load and preprocess audio data, which will take file path, and it will give you our X test. Okay, which we will use, our X test we will use for model prediction. Okay, so we need this load and preprocess function which will return and give us X test, and then we also need this model prediction function. Okay, which will take this X test, whatever we pre-process and return by using this function. That function we will use to compute X test, and then we'll pass that X test to this model prediction function, and it will give us indices of that classes. Okay, so these two things we need. Okay, fine. After this we are ready to start our UI part. Okay, so we have imported our necessary function, like this is load model function which will load the model which we have saved earlier, and this load and preprocess function will pre-process and return us the features, and that feature we will pass to our model prediction, and it will return me and give me this thing. Okay, this indices. If you are watching from here, then please watch this playlist from beginning. This entire thing we have done in detail in my last video. So now we'll do the UI part. So let's write here Streamlit UI. So here first what I will do, I will give some title. So first title I will give st.sidebar, and st.sidebar.title. If I give this, I will write dashboard. So if I do like this, then if I go in my Streamlit UI, then I will see here this dashboard part here. Okay, so this is the title of my sidebar. Okay, so this is my sidebar, and this is the title of that. Okay, so by like this we can define this title. And one more thing we need, so first we have to define the number of pages. So To define the pages, I will give here st.sidebar.select box I will use. Okay, and select box, in select box I will give it this message select page. Okay, and whatever the list of my pages I will give here. Okay, so first page is home page, and second page is about project, and third page is prediction page. Okay, so in this select box we have three entries: home, about, project, and prediction. Okay, so if I refresh it from here, then I will get here select box. This is the message select page which we have defined here. Okay, and this is my items here: home, about, project, and prediction. Okay, so we have defined our application mode. Now we will first work on main page. Okay, main page. So what we will write here, so I am writing here if app mode double equal to home. So if user is clicking home page, then do a work in this. Okay, so in this part first we'll give some markdown here. So I am copying from a GitHub repo what we have done there. So in music genre classification, so this is my music genre app. So this thing I am copying from here. So this entire UI part, first what we are doing, first I am copying this thing and I will explain you what we have done. Okay, so first I will define like this. Okay, so this thing we will get welcome to the music genre classification system. Okay, and then we have to use that image part, so I'm copying that thing also from here. Okay, so this thing will we are defining our image, and then we are defining this thing. Okay, so we are defining our image path, which is this, so we have to use that image. So I'm taking that image from, I have already saved that image in my here, so I'm taking from here music genre classification, this image. Okay, so I'm taking and putting in my demo folder. Okay, so we got our image here. Okay, this is our image. So we are using here st.image. Okay, after this we are using st.image, and we are giving image path, and we are saying that use column width is equal to true. It means that whatever is the width of column, take everything. Okay, use entire column width. So from here to entire column, so here it's taking everything. If I don't give, then whatever is the size, it will consider that thing. Okay, so by doing this we can put here image. Okay, and I've also done some styling. Okay, so you can use this thing from here. So this is a CSS part, so you can use this thing. If you have to put here. Okay, if you do like this, then it will apply styling on the entire application. So we are applying this styling here in this home page only, so that's why I've written like this. Okay, so it's taking this ht app and it's applying this background color, this blue color, and also it's applying this font color to this, and also I'm putting here heading 2 and heading 3, so that I'm saying that also color that heading 2 and heading 3 to white. Okay, if I don't do like this, then it will not apply that font color to headings. So we are using here this headings, this is of h2. Okay, this is heading 2. So I'm going to my application and I'm rerunning it, so I'm getting this thing. Okay, so this is my welcome message, and this is my image. Okay, after that what we are doing, after that I am writing some markdown here. This markdown I am writing after this. Okay, so this is markdown, this is the information about our UI or web application. Okay, so this thing I have to give here. Okay, this is just to tell your user that what is the functionality of your app. Okay, so I'm pasting inside this if statement because it is a part of my home page. Okay, so we have to put this entire markdown and image inside this if statement. Okay, so I've already put it here, so let's rerun it. So here this is the UI of our home page. So this is some messages here, how this app works, how it works. So it consists of upload audio functionality and also perform some analysis and give you a result. Okay, and why we have chosen this, because it is using deep learning models, and it is user friendly, and it responds quickly. Okay, so that's why we are using this. And this is something, so you can mention something about your team and everything if you're building this project. So you can put here that thing, you can edit from here. Okay, so this is what we are doing here. So we have successfully completed our home page. Okay, so now will build our about page. Okay, so same we will do for about page also, no change. So here I will write elif statement. Okay, elif I will use, so that elif, if app mode is home, then display this thing. Elif app mode is about project, then display this thing, whatever I am going to write inside this. Okay, so in this also I have to define some markdown, so again I will take from there. Okay, so some text we have used, so this thing I have taken from Kaggle. Okay, so this is about project. So okay, and this is about data set. So if user click that about project button, then execute this thing. That's why I'm writing inside this. Okay, so let's go to our UI and see. So this is our home page, fine. And if I go inside this about project, then I will get this thing. So this is about project. Music experts have been trying for a long time to understand sound and what differentiate one song from another, how to visualize sound, what makes a tone different from another. This data hopefully to do just that. Okay, so this is all about my genre original. So this data set consists of genre original, which is collection of 10 genres with 100 audio file each, and I've also mentioned the list of genres present in this data set. So this data set having blues, classical, country, disco, hip hop, jazz, metal, pop, reggae, and rock genres. And this is also, they have given image, which is spectrogram image. This thing I have already talked in detail in my first video of this playlist. Okay, and also they have given the CSV file. So entire thing is mentioned in this about page. Okay, and now we have to construct and work on prediction page. Right now it is empty. So first let's give here one comment that this is about project, and then we'll work on prediction page. Okay, so I will give here elif app mode is equal to prediction. App mode is equal to prediction. Then we have to do something here. Okay, so first I will display some headings. So I will use st.header, and I will display something model prediction. Okay, model prediction I will do, and if I refresh it, then I will get this heading model prediction. Okay, now we have to put some uploader on which we will upload our file. So I'm going to use here st.fileupload, st.fileuploader, and in this I will write some message, upload an audio file. Okay, and I will also specify the type of file which is expected here. Okay, so I am giving here mp3. Okay, so this uploader will accept mp3 file, and whatever things is written by this uploader I am recording in this test mp3. Okay, fine. Let's save this and run this. I'm refreshing it from here. So in this is a message, upload an audio file, and this is our uploader which will accept mp3 file. Okay, so from here we can upload any file. Okay, like here we can upload this test music. Okay, fine. Okay, so now what we will do, we have to extract the file path from here, from this test mp3. Okay, because we have already defined here load and preprocess audio file function, which will take file path as input, and it will return and give us xtest, which later we are going to pass to this model prediction function. Okay, so we have to extract the file path from this test mp3. Okay, so how we'll do that? So first I will write like this: if test mp3 is not none. Okay, if there is something inside it, initially it is none. Like if we run this application, right here we have not uploaded any file, so at this time it is none. Okay, so if something is something we upload in this test mp3 file, in this file uploader, then this test mp3 value get changed. Okay, so I am saying that if test mp3 is not none, like something is present in that file upload, then we have to retrieve the file path. So I'm defining one variable file path, and I'm giving here test music because we are working in the same directory. So in this we have our file. Okay, so I'm giving here test music, okay, slash I'm giving. So right now what I'm doing right now, if you want to do any prediction, then you have to put all the audio file in this test music, and then you will be able to do a prediction. Okay, first let's see what we are getting. Okay, test mp3. So I'm printing here. I'm printing my test mp3 file. I'm running it again, and I'm putting some file, like I'm putting this rock music. So let's go and see what we are getting. So we are initially we got this none, okay, when we don't have anything, and once we uploaded that file, so we got this thing. Okay, so this is our entire thing. So right now it's coming from here. Okay, so this thing we can extract. So I don't want to make things complicated, so that's why what I am doing right now, I will use this thing. Okay, and I will append in this, I will write like this test mp3 dot name I will do, because if I do the name, then I will get this name. Okay, if I print this file path, okay, initially it is not defined because we have to put here, okay, inside this statement, so that if there is something, then only it will happens. Okay, because initially it is none, so that's why it's saying like this. So if I go inside this, then we are not getting that error right now. So if I put this, okay, let's go there and see. So we are getting this file. Okay, so this file we want. So if it is not none, then only we will define this file path. Okay, so we got our file path. Now we need that show button. So we have to write like this show button. This is a show audio, or we can write here play audio button. Inside this I will write st.button. So I'm saying that if this button is clicked, then you have to do something. So play audio, this is a button which we have defined. Okay, so inside this I will write like this st.audio I will use, and I will give the test mp3 directly, that mp3 file, this uploader. I'm giving directly this thing. So once this button is clicked, then it will show me whatever here. Okay, so let's do this and see. So I'm going in prediction part, and I'm clicking this button. Okay, so we have uploaded this rock music. Let's click on this play audio. So we are getting this thing. So from here you can play that thing. Okay, so by doing this you can play your audio. Okay, so we have successfully completed our audio playing part. Now we have to do a prediction. Okay, so I will write here predict. So we have to create predict button first. So I'm writing here if st.button. I'm saying that if predict button is clicked, then you have to do something. So first I will define here with st.spinner, so that it will display me that please wait message. sp.spinner, please wait. So first we have to define our X test. So how we will do that? So we'll use that load and preprocess function. This function will use this load and preprocess file will use, and to this we will give the file path which we have defined earlier. Okay, so this is our file path, and then we will define, we want our result indices. So it will get returned by this model prediction function, this function, this one. Okay, so I will define here model prediction. It will accept X test, which we will get from this load and preprocess file function. So this load and preprocess file function will take this file path, and it will give me all the features, and that feature I will pass to this model prediction function, and it will give me result indices, that is index of that class. Okay, which our model is predicting. Now we need classes. Okay, all the labels. So I will take the labels from here. Okay, so here we have defined this thing. Okay, so I'm taking this from here. This is a list of labels. Okay, there is a list of classes in the same in the same way you have to define, you have to write, because in the same pattern our model is trained. Okay, our model will understand that 0 means blues, 1 means classical, 2 means country, 3 means disco, and 9 means rock. We have to define the same list on which our model is trained. Okay, so in the same way you have to give here also. Okay, because our model is understanding that 0th index is for blues and 1st index is for classical and 9th index is for rock. Okay, and then we have to display the message. So I am writing here st.markdown, and inside this I will write model prediction, and I will do model prediction like it's and I will give here curly braces, and I will say here music. So it's our predicted music. So what it is, so for that I will use dot format, and inside this I will define label, and I will give the result index. Okay, result index. So whatever indices is being predicted by the model, I will pass that to my label list and it will give me the prediction. Okay, so let's do the prediction and see what we are getting for this. So first let's refresh it, and here I am uploading some jazz music. Okay, so by clicking this you can play this music. Okay, I am clicking this, so it's saying this please wait, it's running all the things. So up to then this spinner will run once all the things get executed. So it's saying that name model is not defined. Name model is not defined. Why it's saying? We have to go inside this model prediction part first. Okay, so here we are using this model, but we have not defined that model. So first we have to define this model here. Model is equal to load model function. This function we have defined. So we have to use this thing here. Okay, so here we have to define load model. Okay, so we will define our model and then we will do the prediction. Okay, so we have defined our model. Okay, so let's do the prediction. So I'm going here, let's refresh it first. Okay, so I'm clicking and uploading some audio file like this rock music. So from here we can play it. Let's do prediction. So it's saying that it's a rock music and we have uploaded this rock music. Okay, now we can make it more beautiful. Okay, so to make it more good, we can write something like, we can use here this thing. If you use like this blue, and it will color this thing to blue. Okay, and this thing we can color it to red, which is our prediction, so that we get more highlighted prediction. If we do like this, let's go here and let's do a prediction on piano, this classical. I'm doing the prediction. So it's a very big file, 37.4 MB file. So it's chunking and doing the prediction. So that's why it's taking some time. It's saying that model prediction, it's a classical music. Okay, so this is our prediction. So it's by doing this, it like this text become blue and this one become red. You can make it more bold also, make it bold. So just give here this thing. If you give like this, then you will get like something. So if I go inside this and if I use this hip hop part and if I do the prediction, then it will give me my prediction. So it's like the result is a little bigger. Okay, and if you want to put something like if you want to put something like, once you got your answer, then you want some celebration or something, then you can use this st.balloons. st.balloons, you have to use this thing. If you use this function and if you do the prediction, like I'm going there and I'm uploading this hip hop part and I'm clicking on this button, so you will get your prediction like this. Okay, like some animation you will get. Okay, so and one more thing you can do, like here you are once we are clicking this button, this predict button, then every time we are executing this function, we are executing. Okay, this load and preprocess file function, and this function, this model prediction function, also we are also we are computing every time. So this model prediction function consists of this load model part. Okay, so we are executing this load model part again and again. Like right now we have very small model, so that's why it's not reflected here. But if it is bigger model which takes lots of time to load, so for that we can use this streamlit st.cache resource. So by doing this we can store our model in the cache, okay, so that we don't need to do this entire thing again and again. Okay, so if I do like this, then one time once we start, or when we start our web application, that time it will store this streamlit will store this model in cache, and then every time when we call this function, when we call this model prediction function, then it will load that model from cache. Okay, so it will like it is little faster. Okay, so every time once we refresh it, then it is stored there in cache. Okay, so we don't need to reload that model again and again. And once we are doing any prediction, we are testing our model on multiple mp3 file, then also our model is stored in cache, so it will get reloaded from there. Okay, in this web application part, we have started from here. We have used this streamlit library, and we have used this we have constructed this load model function, and we have also constructed this function we have taken from my last video. Okay, so there we have developed this two function, load and preprocess file function, and this model prediction function. So we are using that function, and we have developed these things. Okay, one more thing here, like whatever is the test file on which we have to do the prediction, you don't want to put that file in the test music part, then you have to change this thing from here. Streamlit also have some temporary folder function which you can use to give some temporary path to this test mp3, and it will go here and it will do everything. Okay, so you don't need to define the path like this. Okay, you can make it more generic. So that part I will, if I am going to build some other project in the next project playlist, then I will add that functionality. Okay, so that you don't need to put every time the whatever is your test music in this test music file. Okay, so right now, just for testing and just to show you how exactly we can convert that machine learning model to interactive web application, so that's why I have put it things simple. Okay, because lots of thing here we are doing. Okay, lots of things we have done, so that's why I don't want to make it more complicated. So that's why I have put it in this format, but you can change it. Okay, Streamlit also have that functionality in which you can create a dummy directory, and you can give that directory to your function, and it will work as it is. Okay, it will accept that work. Okay, so we'll do that thing later. Okay, so I think we have completed this project series. Okay, so hope you like this. Okay, so this is the last video of this project playlist, and I hope you all enjoyed this entire playlist. Okay, so that's all for this video. Thank you guys. Thanks a lot for watching this video.